Welcome to the fourth in our series of webinars about Vulcan 10. Following on from the previous events, we now provide a session for the resource geologists. Today, I introduce Richard Jackson from Maptek, New Zealand. Richard, the new data analyzer has been demonstrated to many customers, and I'm looking forward to further sharing this new option with a wider audience during this webinar. I note that it uses a new interface to generate and analyze variograms. Can you give us all a quick overview?
Thanks, Steve. While Vulcan has always included the ability to analyze data and create variograms, the enhancements in version 10 really add ease of use to the package. Data analysis now has a custom interface, which is intuitive and easy to use. Making adjustments to variogram parameters is now dynamic, with settings such as lag size, range, and orientation now adjustable on the fly. Today I'm going to run through the basic functionality of how to get data into the data analyzer, run filters, create variograms, and produce outputs suitable for grade estimation in your final reports. Improvements to our other geostatistics have also been made, and we'll touch on a few that will be of use while creating variograms, such as the new unfolding tools. So for the rest of the presentation, I'll jump into Vulcan and we'll run through these new tools. I'm sure most of you have now seen and are hopefully enjoying the new Vulcan 10 interface, but looks aside, one of the most exciting changes is the ability to have a new and very different style interfaces than we've had in the past. And the data analyzer is one of the first options to utilize this. The data analyzer is located in the Analyze menu, and bringing that up, we will see this new tabbed interface with sections for our data, our variography, and our export. So in the Data tab, we bring our data into the Data Analyzer, create filters, and apply transformations. In the variography, we select our variogram type, create our variogram model, and then export that into our grade estimation. And the export option allows us to make graphics for our reports. To start with, I'm going to bring in some grade control data. So if I go to Open Data, this is just going to select a usual Vulcan composite or samples database. And when we bring it in, we'll see fields. To create a variogram, it's as simple as selecting an element from our database, going to variography, and choosing one of our variogram types. I'll just make a simple variogram. Our properties come up on the right hand side, and we can adjust these now or later as they're dynamic. So that's created the variogram there. I can dynamically adjust the lag size, perhaps to reduce some hole effect due to the spacing of holes. I can change my search radius as well as my offsets and angles. If I do wish to change my variogram mode or other parameters, I have those options there. So at the moment it's on a semi-variogram, but I can change that. I can show my sill and I can standardize my sill to give my variance of 1. Before getting into too much depth with this variogram, I'm just going to make a new variogram, but on the data filtered by rock type. So it's only showing the one ore domain. Back in the Data tab, we can create a new filter. Selecting my database, filter a name. And this is the usual sample selection panel familiar in Vulcan. So I can choose one or as many of these filtering options as I need, but for this data set, I have the lith1 field or variable in my bound AU field. To apply that filter, I can select a variable, hit apply filter. If I have more than one variable or more than one filter, I can select it here. But I can apply that to any of these grade fields where that filter applies. You may end up with a lot of filtered variables in your list, and to help tidy that a little, we can go to the Explorer Visibility, where we can choose to only display things by one filter or one domain type, or more than one of these options. So now we're just seeing our variables that have been filtered to the OR domain. So I'll make another variogram. I'll do one for gold. I'll also do one for copper. So into variography, I can click variogram as before. We see our options on the right, so I'll just leave these as the defaults, but I will check on to standardize the cell. And we'll get our multiple variograms created. There is some control at the top as to whether these are put on the same chart or multiple charts, but I'll just reduce the ranges so it fits better for our closely spaced grade control data. As well as creating a single variogram, we can create fan variograms. So if you're not sure of the best orientation to make our variogram model, the fan variogram will create multiple variograms at an even spacing around the compass. So we can see by default it's going to create 24 steps at 15-degree angle of separation. We can adjust these parameters later, but I'll just run with them for now. Just drop this down a bit for my tight grade control data. And just doing this for gold in this instance. So that's generating the multiple variograms, one per 15 degrees, and for all of our different variogram modes, so our semi-variogram, radiogram, all of our different variogram modes. It's just ticking along with the progress bar there, and then we'll pop up. Okay, so we'll just shrink this down a little bit to see our tightly spaced data. So with our fan variogram, we can dynamically drag the orientation to see each of the graphs at each of the orientations. But we may also want to see all of these charts at the same time. On the bottom toolbar here, we have some visibility options on how we want to display the charts. And the first one we'll just turn on is the multi-variogram. So this will show all of the 15-degree increments on the same chart. I'll just turn off my major direction chart there. And to help me see, I'm just going to turn off this legend. We've been looking at the properties for the variogram parameters, but we can also change the chart settings. So if you want to display a legend or change a color or a range or a label, all those options are in here. As well as viewing all of these orientations on the same chart, we may wish to put them all onto separate charts. So we have the variogram grid option down there. So looking through these, the azimuth 135 may be a good place to make my variogram model, a good place to start. So I'm going to have a look at that. Just orient my fan there, turn off my grid, turn back on my major axes. As well as making the primary fan, it has made the secondary fan as well, so we can turn that on and we can orient this as we see fit. And if we want to display our minor direction or turn that off, we do have control for that as well. So using this data, I'm going to make my variogram model. And we do that with this last tab here in the properties to make a variogram model. I'm just going to change the color of that to make it easier to see. And when we create it, there are a few different ways. I've just checked on the auto fit, so Vulcan's going to run through multiple iterations to find the best fit model for that. As well as that, we can manually grab a hold of these control nodes, move them, or we can type in the nugget and cell manually there. What I should have done before I started is clicked on standardized cells, so I'll just check that on. just to give the variance of 1. And if I did, instead of wanting to use the autofit, wanted to type in these manual directions, I can do so. And we'll see that update on the chart. So I'm just going to drag that to where I think it might fit if I'm not using the autofit. And while this data doesn't need it, we'll have a look at how we can make another structure. So the type of structure that it's fit is a spherical model, but if we want to change that, we can do so here. If we want to add another structure, we can tell it to do one there. So now we can see the icons for 2 structures. I can type in parameters for these second structure. And I can drag it manually to where I want it. When you drag it, you can use your shift and your control keys, which will just lock either the sill or the range. So when it gets dragged, only one parameter will get updated. When you do drag it, you may have noticed that the first structure was affected. If you do want that to be locked, I can pick my first structure and check on these little radio buttons to lock any of the parameters for it. So now adjusting my second structure won't affect my first structure. I'm just going to update these values. Perhaps I know based on my other data what nugget I want. And that there is my final variogram model for this data set.
Richard, the variograms look very impressive, especially when compared with Vulcan 9 and earlier versions. Having created them, how do you get the parameters into the grade estimation tools?
So within the Vulcan Data Analyser, we have the option to save. And what this will do is save our data analyzer work, so including our filters, what variogram charts we've made, everything that we're seeing on the screen now we'll be able to recall. But if we want to get that data out of the analyzer and into other parts of Vulcan, we have the option to export our variogram file. So clicking on that, we'll make a standard Vulcan variogram file, .vrg. And if we go into Vulcan and look at any of the options that use variography, such as grade estimation, if we select an option like ordinary kriging that uses a variogram file, then we'll be able to pick that VRG file. So I'll come into my variography, select the file we just made, and I have all my parameters that I just saved.
Now I note that there's also the ability to generate downhole variograms. Can you show us how to use this option?
To make a downhole variogram, I'll just bring in a second data set into the same data analyzer window. So I'll just go to Open Database, pick a second composite database. I will turn off my filters that I had on to filter just by OR, as I don't have any filters run yet on this new data set. And if I select this composite database, I'll see in the properties the option to specify a depth field. So if I pick the 2 depth, that tells Vulcan what field in the database to use for the downhole depth, and that's all I need to set up to make the downhole variogram. To run the variogram, just as before, pick a field, tell it to create a variogram, turn off the single direction, and tell it to make a downhole variogram. And I'll just update this to reflect the length of my holes. And when I run this, it will give me a downhole variogram.
Richard, I've just completed 2 consultancy projects which required estimation of resources for complexly folded strata. How do you incorporate these unfolding parameters into the variograms?
Within the data analyzer, it's just a click or two to incorporate that unfolding, but we'll just first look at why we might want to use the unfolding. So on screen I have some samples from the second database I loaded, and the two surfaces representing the hanging wall and the footwall of a particular unit. What we can see here is that the data does appear to be folded, and if it is post-depositionally folded or it's been deposited in a way that the floor or the footwall of the unit has a varying grade to the hanging wall, it may make sense to unfold those samples before we do the estimation or the variography. Why we might do that is, if we're going to look at the variance between samples, and we look at a sample here and take the overall dip or plunge of the unit, it'll pick a sample from a similar stratigraphic position in this following hole, but in this other direction, it will pick one right at the footwall, which may have quite a large variability, and it may not be a true reflection of the data as if we had unfolded it. So what we're going to do is do a method called projection unfolding, where it's just going to project the hang wall surface down to a flat plane, the footwall down to a flat plane, and all of the samples that lie within it will get their relative position within that. So essentially keeping the X and Y coordinates the same and unfolding the Z to a flat plane. The heights do change for the Z coordinates, and you'll see that they change between 0 elevation for the footwall and 1 for the hang wall. And there's a really good webinar on our website which explains in detail this unfolding, and not just the projection method, but the other methods we have available within Vulcan. So with that in mind, we can set up the unfolding file, which is in block unfolding, create an unfolding model. Like I said, we're going to use the projection method, and that just takes our two surfaces, and it will use this when it does the variography or grade estimation, wherever we want to use this unfolding. This method's been used a lot in flat-lying deposits like coal deposits, but it hasn't been so useful for subvertical deposits in previous versions of Vulcan because it projects onto a horizontal plane. New in version 10 is the ability to project onto a non-horizontal plane. So the same logic can be applied to steeply dipping deposits. But we'll leave that as is. We've made our tetra file, which includes the unfolding. Now if we go back into the Vulcan Data Analyser, we'll run this unfolding. First we'll just make a filter so we're only selecting samples from that one unit. So back to our data tab, make a new filter. So on this new database, just give this filter a name. And again, using the character variable, the character filter. So I've got an OR code for the samples within that unit. I can apply that to my iron. And now I'll run the variography. I could do this on any of my variogram types, but I'll do it for a fan variogram like before, leaving my defaults, but I will increase my radius and lag to better suit my more widely spaced data set. And I could turn on my unfolding beforehand, but it's easy to add it at the end as well. So this is my data set as is. Just normalize, standardize the cell and show that. And what we're seeing is as the range increases, it's increasing variability as we'd expect. But then at some point it's decreasing variability, which is an unusual variogram trend. So this is on the not unfolded data, the data as it is. Perhaps what we're seeing there from the variogram trend is as our data goes from one limb into another, we're increasing variability, perhaps moving from the hang wall to the footwall. And then when we go back into the other limb, we're decreasing variability again. To test that, we should see an improvement in the variogram if we do the unfolding. So I'll turn that on, pick the tetra file that we made before, and give that a second to redraw, and it's unfolded the samples and it's giving us a much more familiar variogram shape. As well as turning it on, we may want to think about this vertical tolerance. If you remember before, we transformed the Z values into a space between 0 and 1, with 1 being the hanging wall and 0 the footwall. So this tolerance, which is in our units we're working, we may want to drop to a smaller number. So by putting 0.2 in there, it's not as much saying 0.2 meters, but it's saying 20% of the unit thickness, because we have transformed that space. And again, that's improving the quality of the variogram.
From experience, I know that the number of variograms for some projects accumulate quite quickly. How do you get all these variograms from the data analyzer into your project reports?
The last tab that we have there is the Export tab, and this allows us to export what we have on screen into our reports or into another program like Excel to graph. Remember, before we export, you do have the options to change labels and colors in your chart settings, but if you're happy with what you've got, we can export as a PNG what we have on screen, and we can increase the resolution up here. As well as exporting this as a graphic, we can export a CSV file, and that will have all of our ranges with the values. So if we open that up there, for each one of our orientations, for each one of our ranges, we'll have the distances, pair counts, and all of our variogram parameters.
Now, Richard, we have a couple more minutes before answering questions. So what other changes have been added to Vulcan 10 that could be of use to the resource geologist?
We'll have a look at some of the new features in version 10 for geologists, but one that's very useful but not specific to geologists is this new command list. So what the command list allows us to do is provide a workflow to the menu items that we use in Vulcan. Before, when we pick our menu items, they're all grouped by file type or job type. So our geology drilling tools are in one menu, separate from our block model tools. So this workflow allows us to group what we want in either a single list that we follow through step by step, like we've got here. To add something new into this, or to create it, we can go into the Workbench Customize, and what that will bring up is the command list where we can drag any option from any of the different Vulcan parts, so Envisage or ISIS, or the block model utility, and down the track we'll be able to use options from the other Maptek products. So if I didn't have my grade estimation on this and I wanted to add it, I could just go into Envisage, go into grade estimation, and just drag that into where I want it to appear on the list. So maybe after I make my block models, I can give it an instruction, so we'll see that as a prompt. So run ordinary kriging, and we'll save that file. So we'll have a look at some of the new options available in version 10, but I'll just bring up the menus from this command list. Some of the new options that we have deal with making things more transparent and easier to use within Vulcan. So one of the things we've always had is the ability to find our search distance and orientation, but now we have the ability to interactively see where that orientation is. So if I select on screen, I can now see that axis. If I change my plunge, I'll see that update. And to make that a little easier to see, I'll jump into plan view, and I can see my ellipse there. As well as dynamically updating with the numbers entered, you can drag these axes or rotate them to orient it with your model. Other options that we have are new options in the simulation. So if you're running simulation, you can now use these unfolding options we talked about earlier. There are also new options in the implicit modeler. So we'll bring that up from my command list. So there are a few new options to be aware of in here. We can now use RBF or radial basis function interpolation as the estimation method. And in the advanced options, we can also model uncertainty. So when we are perhaps modeling the volume of a particular ore domain, we can also get it to make more optimistic and more pessimistic results. And it does store the variance of this in the block model. As well as the implicit modeler, we have a new vein modeler, so that's hiding in the geology vein modeler menu. And what this does is it takes the grid-based mathematics, which works so well with flat-lying coal deposits, and applies this to narrow vein deposits by unfolding the data so it's in a flat plane. The big advantage with this vein modeler is, as well as modeling the hanging wall and footwall, it does think about the vein thickness and tries to keep that consistent where there's not much other data. So they are the new tools to keep an eye out for version 10. Those last two options, the vein modeler and the implicit modeler, will have webinars in the upcoming weeks. So keep an eye on the Maptek website to sign up to those.
Thanks, Richard. Your presentation has received great interest, and I've got a few questions here for you to answer for our audience. First one, where can customers get the new Vulcan Data Analyser module?
So the Vulcan Data Analyser will appear with Vulcan 10 for anyone with a currently maintained Geostat modeler license. In addition to that, it can be purchased as an add-on to other license configurations.
Okay, and the command list with all the resource geology operations on that, is that able to be shared?
Yes, certainly. So when we make that command list, the last option it will specify is that it will save it. And so it makes a WVC file, so one person in a department can create this for other staff to use, and you can transfer it with Workbench load customization file. It's a very useful new tool, so if anyone wants to have my command list or that they can then later customize or want some help with it, feel free to contact me or one of the other Maptek staff for help with that.
And a final question, what are the future development plans for the data analyzer? We've had one customer ask how whether we can put the EDA or the statistics functions in there, so what are we doing there?
That's certainly where we're heading with this. So at the moment it is what we've seen, just doing the variography, but the development team's currently adding in all of our statistics options, line diagrams, histograms, PP plots, cumulative frequency plots, all of the usual statistics options you would expect. Because it's such a simple interface to use, it's really where we want to go with not just variography but all of our statistics. And we are looking at adding in other data types such as block models as well.
And I'll have a last-minute question, which I'll answer, which has come in that a customer likes to be able to use non-composited data in the analyzer. And currently, the data analyzer supports compositing databases. So the geological databases will be in Vulcan 10.1, just your standard ones. But I guess you can do a straight composite, which converts the geological database into the Vulcan compositing database file, and then has that ready so that you're not doing any anything with your sample intervals.
Yeah, that's right, Steve. And one of the composite databases that I used today was a straight composite database. So while it's converted it, like you say, into a acceptable file format, it hasn't actually done any averaging or cutting of those samples.
Yes, and just a final clarification, a customer about the unfolding options and which one can be used with the variograms, and I believe that all the supported ones of projection, bend and LVA are supported as the VDA. Richard, thank you very much for providing an overview of some of the new resource geology options in Vulcan 10. Obviously, in the time available, you've given us a nice overview, but there's a lot more depth there. And if customers are interested in following up, I know we do have some outstanding questions, but just for timekeeping purposes, we'll answer them privately. Please contact myself or Richard. Our contact details will be on the screen soon. And note that there are other webinars in this series, as Richard mentioned from time to time. The next geological one will be on implicit modelling in a couple of weeks' time, followed on by other ones with mine planning and Eureka for exploration. With those webinars, we do recommend we're registering fairly early because the demand is becoming high. If you do miss out or your colleagues miss out, we do record these and then post them on maptek.com/videos at a later date. Thank you again, Richard, for sharing that session this afternoon. I look forward to seeing and catching up with people on the next session, and thank you for listening, and bye for now.